Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics. We will discuss under that quasi-static process and non-quasi-static process. Understanding this topic is very important because this will help you understand the derivations related to the various types of thermodynamic process. But before we start the topic, please watch the video completely so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends who may also be benefited. And also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. And also press the bell button and all button for notification of new videos like this. Now let us start the topic. We will see types of thermodynamic processes. Thermodynamic processes are classified on the basis of different criteria. In this video, for the sake of easiness of study, we will take one criteria, that is speed of the process. On the basis of this, it can be classified into two. Those processes which proceed at a very slow pace, that is infinitesimally slow process. That is very slow process. And another type which proceed at a fast pace, that is thermodynamic processes can take place very slowly or very fast. In nature anyway, most of the thermodynamic processes proceed at a very fast rate. Slow processes do not really exist in nature. Then why do we discuss these infinitesimally slow processes? It is because the fast processes proceed so fast that they are not manageable. The various changes or steps or the work done or the transfer of heat and other forms of energy cannot be easily studied. So it is better that we understand the slow processes first, derive the various equations, and then apply that to the natural phenomena. I hope you understand this. Now, these infinitesimally slow processes are called quasi-static process. Quasi-static means almost static, that is without change. That is, the state variables are almost static or remaining without change. That is, the system is in equilibrium. We have already discussed that in the previous video. If you have not watched that video, click the I button to watch that video. When a thermodynamic process is quasi-static process, then it passes through several stages or steps, and in each step the system is in thermodynamic equilibrium. Such steps are easy to understand, but these processes are ideal processes, that is not real, only hypothetical. Okay, what do you call these fast processes? The fast processes are called non-quasi-static processes. Let us cite two examples for these non-quasi-static processes, that is, fast processes that take place in nature. First one, sudden expansion of gas in vacuum. Second one, the explosive reaction that takes place when a mixture of petroleum gas and air is ignited. Let me cite one more example in daily life in order to understand quasi-static and non-quasi-static process. Consider a staircase and a person standing on top of that. To reach the ground, he may either use the staircase or jump directly from the top. If he is using the staircase and climbing down the stairs, his movement will be very slow, but at each step he will be more or less stable. That is, he will be almost stable. This is not a thermodynamic system. Only we are citing an example to understand the slow process and how at each stage the process is stable. This can be compared to what happens during an infinitesimally slow thermodynamic process, that is a quasi-static process, when the process passes through several stages and each stage is in almost thermodynamic equilibrium. Now consider the other option. The man is suddenly jumping down from the top. The process proceeds very fast. This is the path that he traverses. The process is so fast that nowhere in between his path he is in equilibrium. This can be compared to non-quasistatic process. The non-quasistatic process is proceeding at a very faster pace. The quasistatic process proceeds very slowly, step by step. Each step in the staircase can be compared to the various stages, that is stage 1, 2, 3 and so on in the thermodynamic process. I hope it is clear. Now we will discuss an experiment to understand non-quasi-static process. This is a piston cylinder arrangement containing a gas, as you can understand from the picture, is under pressure. These are the weight. This is the piston. Now the pressure on the gas is equal to external pressure. Temperature equal to external temperature. This system is in thermal and mechanical equilibrium with the external surrounding. What happens when the weights are suddenly removed? This piston, which was in this position initially, now accelerates upward. This is because the gas suddenly expands. This is more or less similar to sudden expansion of a gas in vacuum. In the final stage, it is in thermal and mechanical equilibrium with the external environment. The gas passes through several stages or steps before attaining this final stage. But nowhere in between the initial and final stage, the gas is in thermal and mechanical equilibrium with the surrounding. Work done is equal to P delta V. But since the stages are not in thermal equilibrium, this equation cannot be applied here. This is non-quasi-static process. Let us pass on to quasi-static processes. In this case, the same setup is considered. In the previous case, all the weights were removed suddenly, but here the weights are removed step by step. In the first step, the red colored weight on top is removed. The gas expands slightly and pushes the piston slightly upward. In the next stage, the yellow colored weight is removed. The gas expands further by a small degree and pushes the piston slightly upward. In the third step, the green colored weight also is removed. Gas expands by a small degree and pushes the piston to the final position. The gas has expanded from the initial level to the final level through 3 steps. That is, very slowly, step by step. Similar to the person climbing down the stairs. The volume of the gas increases very, very little during the first step, second step, and third step. The process is so slow that it can be considered that the state variables remain almost the same throughout the 3 steps. Such a process is called quasi-static process. As already stated, quasi-static processes are ideal or hypothetical. They do not exist in nature. Each stage is approximately in thermodynamic equilibrium with the surrounding. That is, the state variables are approximately static. That is what is meant by the term quasi-static. Let us put together all these points and make a definition. By definition, quasi-static process is an ideal or hypothetical infinitely slow process where the state variables like pressure, volume, temperature, etc. change very, very little, so that at each step the system is almost in thermodynamic equilibrium with itself and also surrounding. Let the initial values of the state variables be Pi, Vi, and Ti. It is approximately equal to the state variables of the first stage, that is P1, V1 and T1, approximately equal to the state variables of stage 2, namely P2, V2, T2, approximately equal to the state variables of stage 3, that is P3, V3 and T3. We have considered 3 stages. Since the system is in equilibrium at each stage, Delta W, that is the small work done during each stage, can be calculated using the formula P delta V, and dW for each stage, that is dW1, dW2, dW3, etc., can be integrated to get the whole work done when the system changes from the initial stage to the final stage. That we will discuss in the next video. If the video was useful, do like the video and share it with your friends who may also be benefited. If you are watching without subscribing my channel, do support me and subscribe it now. And also press the bell button and all button near it so that you get intimated as soon as new videos are posted. Thank you very much for your support. We will meet in the next video with the next topic. Till then, bye. Take care.